Assalamu alaikum. Hello everyone. I hope you're all doing well. My name is Yusuf Hassan. I'm Egyptian. I'm a third year control and automation student. In this video I will be explaining to you a little bit about the project that Professor Claudia gives you in the semester. So a little bit about the project. I personally think that the project is something very beneficial because it helps you improve your theoretical research part and doing the application of the project, which makes you see the fruit of what you are learning in your subjects. Because theory isn't everything, application is also important. So in our last year's measurement and sensors project, we had the fortunate chance to do something like an oscilloscope simulator, you could say, or a design for an oscilloscope on MATLAB. So what is an oscilloscope, first of all? An oscilloscope is a measurement device, an electrical measurement device. So you have this device over here, and it has like wires coming out of it called probes, and you connect it, for example, to an electrical circuit, and it shows you in a time function manner. It shows you the signals or the waves and the fluctuations of it. So for example, if you connect it to a circuit, you could see the sine waves or a square wave or something similar to that. It was a very fun project. We had fun doing it, and I will be explaining it to you now. Also, the year before that, we had the chance, and at least in the course, we had the chance to see a project where we did a steps counter. So just like how your phone calculates the steps when you are walking, it does the same thing while getting your location from Google Maps. So that's about it for the tiny explanation. Now let me show you the project. Okay, hello once again. Now let me show you a quick overview of the project. This is what was required from us. We had three different parts. First one is a simulation where we get the equations and we write down the explanation of it. The second part is the actual virtual interface of the oscilloscope that we did on MATLAB. And finally, we were required to connect that oscilloscope that we did with Arduino to get real-time signals. Okay, so this is our submission. This is our first task. We had down the information about the circuits. We did their diagrams, how they should look like. We simulated them on MATLAB and Simulink. We wrote down the equations of it. For example, we had a Wheatstone bridge and some of the op-amps. We had to do them as well. We did their connection equations. We showed their diagrams. This was for the first task. The second one, which was the oscilloscope itself, is this one. I will show it to you very soon now. So this is how our oscilloscope looked like in the end, and this is how it also looked like. And finally, we connected it with Arduino, and we saw how they look like in the end. These are some of the diagrams or schematics for our project. I will now be showing you how our oscilloscope interface looked like. But before this, I will show you how an actual oscilloscope looks like. Okay, so after seeing how an actual oscilloscope looks like, that picture was taken from our lab. It's a lab that you are going to attend in the third year. We were doing a Wheatstone bridge actually, so that was one of the things that we did in the measurement and sensors project. Now let me show you how our oscilloscope looks like when we open it. So we open it like this, and then we have time scale and volt scale, where we can change how it measures it on the graph. And we have a channel for sine functions and a channel for square functions. So let's try this. For example, I will set them out like this, increase some of the amplitude, and then when I increase the frequency, we should start seeing the signals. Yes, just like this. And now if I play a little bit with the scales, we should be seeing them differently like this. And you can once again change the signals and the frequency of it. the higher the amplitude, the higher that you will be seeing the wave. The less the frequency is, less the waves that you will be seeing. And this can acquire signals from the actual Arduino circuit as well. Now, finally, for the last part, I will be showing you how the Arduino is gonna connect or react with our oscilloscope. So this is here, it's like a simulation of what it would look like. So this is the digital signal. If we press on the button, the time scales look like this one. You get a graph like that. And then here, when we do it in an analog input, so we have a potentiometer and we can change the input like this. That's how our signal changes as well. And finally, we have our Wheatstone bridge, and this is the one that you saw in the picture of the oscilloscope, the real picture. This is how it would look like in a simulation, for example. And yeah, that's about it. Thank you very much for watching this. I hope you have a good time in Professor Claudia's lesson, and good luck with your projects.